Okay, so this is the third review video of Unit 7, and we're going to talk about acids and bases. Okay, acids and bases. So a good place to start would be basically what is an acid and what is a base. Okay, to know anything about how acids and bases react, it helps to know what they are. So we're going to start back in the late 1800s with a guy named Svante Arrhenius. All right, so he's working in the lab, and he makes an observation that if you, there's a beaker here, if you take a compound, let's say table salt, and you put it in a beaker full of water, it dissolves, right? You stir it up a little bit, it's going to dissolve. So what happens when it dissolves is that NaCl is splitting up into Na and Cl ions, okay? So those ions are just floating around in a solution, all right? So what's happening is the sodium chloride is splitting up into sodium and chlorine ions. All right. So what he did was he based his definition of acids and bases off of this. So he said an acid is just something that, when dissolved in water, it increases the concentration of hydrogen ions in the solution. So if you have an acid, for example, hydrochloric acid, hydrochloric acid in pure form is a solid. Okay, if you take that, let's write it over here. You take hydrogen chloride, put it in water, you're going to have H plus and Cl minus ions. So that's an acid because it obviously increases the concentration of H plus ions in the solution. Okay, so some examples of acids. You have one we just looked at, hydrochloric acid. All right, you have sulfuric acid. You have hydrofluoric acid. Okay, we could go on and on. But basically what they all have in common is hydrogen. The cation in those compounds, the positive ion, is hydrogen. So when you put them in a solution and they dissolve, okay, each one of them is going to increase the amount of hydrogen in that solution whenever it splits into ions. So that's what they all have in common, is the hydrogen. Some other things about acids. They react with some metals to produce hydrogen. Okay, if you just watched the activity series video, or if you remember from class, whether or not they react depends upon if the metal is higher than hydrogen in the activity series. Okay, they turn pH paper red, which we'll talk more about pH in just a minute. Okay, and they taste sour. Okay, so you might be thinking, taste? Who would want to taste an acid, right? It's going to burn you. Well, as it turns out, acids are in a lot of foods. For example, citric acid is in a lot of fruits, lemons, oranges, that kind of stuff. Soda has acid in it. A lot of things that you eat and drink do have acid. They may not be as strong as concentrated, but they are acids. Okay, so that's basically what an acid is. So now let's talk about a base. A base is, again, when dissolved in water, water is the key here, it increases the concentration of hydroxide ions in solution. Okay, so let's do the beaker example again. Oh, all right. So we got a beaker here. I know I'm a great artist. Full of water. And I take sodium hydroxide, a common base. All right. It's a white powder. I dump it in the water, dissolve it. It's actually a very exothermic reaction. But anyway, it eventually will dissolve. So when it does so, we're going to have sodium and hydroxide ions floating around. So sodium hydroxide is a base because it increases the concentration of hydroxide ions. That's what makes it a base. So as you can probably guess, bases are going to have hydroxide in common, just like acids have hydrogen in common. So some common bases are going to be sodium hydroxide. All right, you might have potassium hydroxide. You could have magnesium hydroxide. There are a lot of different ones, but basically, if it increases the concentration of hydroxide ions, it's a base. One way or another, it's a base. So some other things about bases. We said, whereas acids taste sour, bases taste bitter. Okay, bases are often slippery, kind of like soap. They feel slippery. They turn pH paper blue. So acids turn pH paper red, bases turn it blue. We'll talk in a minute about what that means. All right. So what pH is, scrolling down here, pH is basically just, no idea how that happened. pH is a measure of acidity, more or less. It's just measuring how much of an acid something is. So it's on a scale of from 1 to 14. pH is measured on a scale from 1 to 14. So acids are below 7, okay? Low numbers, below 7. So, for example, 1, 2, 3, those are all acidic pHs. So, as you probably expect, bases are above 7. High pHs, 13, 14, 12. Those are all high pHs. Those are basic pHs. And neutral is something if it's near 7. If it's near 7, it might be slightly acidic or slightly basic, but it's pretty much neutral, more or less. So that's basically what an acid and a base is. From there, that really helps you understand how they react. So I would recommend looking up some household products, finding out what some household acids and bases are. You might be surprised to find out how many things that you work with, or you use, or you eat every day that's actually an acid or a base. Okay, and the really nice thing about acid-bases reactions is they're pretty easy. So let's start out with double replacement, because if you remember, previously we talked about how synthesis, decomposition, combustion, single replacement, all those generally go through redox reactions, okay, which is one type. Double replacement is the different one here. Double replacement can go acid-base, or you can have precipitation reactions. So double replacement reactions are either going to be acid-base or they're going to be precipitation. One or the other, always. Always, always. So, let's start out with a couple simple acid, or a simple acid and base, and let's see how they react. So let's work with hydrofluoric acid and sodium hydroxide. Examples we used earlier. Okay? Now both of them are going to be aqueous since they're dissolved in water. Okay? Now, when they react, again, acid-base is a type of double replacement. So hydrogen and sodium, these are the positive ions. They're just going to switch places. That's the double replacement thing going on. So if they switch, we have NaCl and HOH, right? Well, HOH, if that doesn't look familiar, it's because when we write that, we normally write it as just H2O. Okay, let's add in our phase symbols. Salt dissolves in water, so it's going to be aqueous. And water is a liquid. So that's what we make, water and salt. So it works just like any other double replacement reaction. You switch the cations or switch the anions, however you want to look at it. The nice thing is, in an acid-base reaction, let me write this down, in an acid-base reaction, the products are always water and a salt. The products are always, always, always going to be water and a salt. Now in this case, the products were water and table salt. You know, common salt, when you hear the word salt, you think of NaCl. However, there are actually a bunch of other chemicals that are classified as salts. So it's not necessarily going to be NaCl every time. It's going to be water and some type of salt. So let's try another one. Let's try, let's do a fairly similar one. Hydrofluoric acid and potassium hydroxide. Okay? Both aqueous, dissolved in water. Alright, when they react, again, switch the cations or switch the anions, however you want to look at it. So we'll say we switch these two. Alright, so we switch them, and again we get liquid water and this time our salt is going to be potassium chloride instead of sodium chloride. And we got water again. Let's finish that. Okay. So water and a salt, acid-base reaction. Works the same way. Let's try a different one. Let's do slightly trickier here. Sulfuric acid, which is H2SO4. It's hydrogen and sulfate. Reacting with, let's do magnesium hydroxide. Okay, sulfuric acid and magnesium hydroxide. Alright, when they react, we're going to switch the hydrogen with the magnesium. We're switching cations there, it's a double replacement. Okay, and you're going to get water, obviously. The H and the OH are going to be water, which is a liquid. And you're going to get a salt, which this time is going to be magnesium sulfate. Okay, you're going to get magnesium sulfate. Alright, so let's balance this equation. If we have, oh, you know what? It might already, yeah, already balanced, I believe. Nope, not quite. And Okay. I thought myself for a second there. So, sulfuric acid and magnesium hydroxide are going to make water and magnesium sulfate, which is your salt in this case. Okay. So, again, I'm going to keep saying it, for any acid-base reaction, the products are going to be water and a salt. You do it the same way as you would do a normal double replacement, but it just helps you to know the product is going to be water and salt. Okay, so let's try. I'm going to give you guys 2 more, and I want you to pause the video, try the problems, and unpause it to see if you got them right. This should be pretty quick. So let's try hydrofluoric acid reacting with lithium hydroxide. So predict the products, balance the equation for that one, and let's do phosphoric acid, H3PO4, and we'll react it with calcium hydroxide. Alright? So predict products, make sure your subscripts are right, balance the equations, and you should be done. Okay, solutions time. Let me move these down here so I got a little bit of room. Nice thing about smart boards. Alright, so, let me get that out of the way. I need to write over there. So we're going to mix hydrofluoric acid and lithium hydroxide. Okay, acid base, so we're just going to flip-flop. I mean, it's a double replacement, so we flip-flop cations. Our products are going to be water, okay, which is a liquid. Messed that up. Water, which is a liquid, and our salt, which in this case is going to be lithium fluoride. Okay, and this one's already balanced, so that's the nice thing. So, pretty easy there. Let's try the next one. We're going to switch hydrogen and calcium here. Those are our cations. So for the first one, we're going to have calcium and phosphate. Okay. So calcium is a 2+, phosphate is a 3-. So crisscross those charges, and we're going to need to have Ca3PO4 2. Okay, Ca3PO4 2. That's calcium phosphate. So that's our salt. So obviously, don't even need to look at the rest. We got water. Water's a liquid. Oh, sorry, I forgot off the aqueous here. So, there's our water and salt. Calcium phosphate and water. So, if you got those, awesome. If you didn't, go try some more practice. You can come see me before or after school, and we'll get it figured out. That's it for acids and bases.